Yes, sir. We are recording the session, sir.
Okay, okay, thanks. Guys, could you just confirm, guys, is my audio and the video is clear enough?
Yes, sir.
Yeah, it's okay, sir. You can carry on.
Thank you, thank you. Yeah. So in the morning we have discussed about, right, in the morning session. So we discussed about HDFS, which is part of Hadoop, which is for which serves as the storage framework for Hadoop. And this session we are going to concentrate on Yarn, which is a computing layer of Hadoop. So what is Yarn? How does it works? You know, in a similar way that we discussed about HDFS, we shall look into this Yarn and how does it work and what is it and what are the features and everything, what not everything. So Yarn simply it stands for, you know, it's an acronym for yet another resource negotiator. So the name should you know, imply something, right? The name of any technology, anything, it should imply, it should convey some information to us. Yet another resource negotiator. This means that it is another resource which is negotiating some resources. Sorry, it is another resource, you know, negotiating. So how would, you know, what was the issue? And what was there anything? Was there anything negotiating the resources earlier to Yarn? And is this something new? And what's it actually? What is the background of this? So in the early versions, actually, I mean, in the early versions, in the sense, in the Hadoop 1.x versions, we had HDFS and sorry, we had HDFS and we had MapReduce. Okay, so HDFS was the storage layer and MapReduce was the computing layer. So I will, this would be a bit confusing now, but I will try to give the clarity on what exactly MapReduce and what exactly is Yarn. Because some people use MapReduce as an engine, an execution engine, and it is also called as the, you know what, resource negotiator as well as computing framework. So in what way it is called as a execution engine, and in what way it is called as a computation framework? So we'll try to understand that. So in Hadoop 1.x versions we did not have Yarn. It is being introduced from Hadoop 2.x versions, and it is called as yet another resource negotiator. So first we'll try to understand what is this Yarn and what is architecture and everything. Later we'll try to understand the differences. What was the earlier version of this computing, and what is that we have new in this Yarn, new version of this computing. Let's try to understand all that after a bit of, after a certain amount of time. So it is a computing cluster of Hadoop, whereas HDFS is a storage layer of Hadoop. This is obvious to everyone. So similar to HDFS, you know, as HDFS is fault tolerant, highly available, scalable, right? Similar to that HDFS, Yarn is also highly fault tolerant, highly available, and scalable distributed computing cluster. That was storage cluster, and this is computing cluster. Now here I need to make a point very clear to everyone, guys, here. So let's say we have in Hadoop we have 100 nodes. Let's say we have a cluster of 100 nodes, 100 worker nodes. When I say nodes, worker nodes. So in how many machines we have Yarn installed, and in how many machines we have HDFS installed? Let me repeat my question. So we have 100 nodes cluster, 100 node cluster, and in all of these Hadoop is installed. Okay, in all of these 100 nodes Hadoop installed. In how many of these nodes we have HDFS installed, and in how many of these nodes Yarn installed?
Sir, in whichever machine we have HDFS, we will also have the Yarn for computation available. So it would be 100 only.
Correct. So don't get into a misconception that HDFS and Yarn are totally different, but they are tightly coupled together. Remember, Okay, so if we talk a master machine, a master node, so in the morning session we have discussed this. I've shown you this. Sorry, in HDFS, sorry, in Hadoop, I have shown, I think that, okay. So see here, on every worker node, we will have a data node, which is the worker process of HDFS, worker daemon of HDFS, okay. And we have one more NM, NM is called as node manager. I've listed here, node manager. This node manager is the daemon of yarn, okay, worker daemon of yarn. So in worker node, we'll have the data node, which is the process corresponding to HDFS, and node manager, which is the process corresponding to yarn. Okay, so every node is utilized for yarn as computation, used for computation as well as for storage. Remember that. Okay, so this is one of the limitation actually. This is one of the limitation, that is same node is used for computation as well as for storage. So in the recent technologies, whatever, someone has asked in the morning session, that one of our friends, if we have emerging technologies which are dominating Hadoop, still why do we have Hadoop? Because certain projects are still relied on, this Hadoop. There's a reason still they support these services. Now, but one of the limitations of this Hadoop is same machines, same set of machines are being used for storage and computation. That is the issue. That is a not issue actually. It's a limitation. But because HDFS and yarn, they cannot be decoupled. They are tightly coupled. They exist always together. Okay. So the recent technologies, whatever we have shown you in the morning with respect to storage, they are used only for storage. In the morning I have shown you read just something like HDFS. Sorry, S3, blob storage, data lake, and cloud storage. These are only for storage purpose, not for computation. But we have another services which are used for only computation. So this way, the services that are there already in the cloud, they're dominating this Hadoop. This is the reason. But remember here, in case of Hadoop, we do have both. We do have same set of machines for storage and processing. Remember, so in the master node we'll have name node. In the master machine we'll have name node and resource manager, which is the master process. And in the worker machines will have data node and node manager. Okay, I will show you that very quickly here. So this is the master node we're connected to. Okay, so if you want to see the process running inside this machine, I mean the Java JPS gives the list of all the Java processes running in this machine. So if it doesn't show all the process with this JPS, you try with just sudo JPS. It should list out all the processes that are running as part of this Hadoop, Hadoop cluster here. Do you see name node here? Yes, we have name node here, and also we should see resource manager here. Resource manager. Okay, so we won't see data node and node manager in this one because this is the master machine. Okay, so if you want to see data node and node manager, we should connect to a data node. We should connect to a worker machine. Data node, we should connect to a worker node. Then we will be able to see them. So I will show you maybe after some time. If I forget, just remind me. I will show you how do we connect to that worker node and the list of what we call as a process that we see that run as part of the worker node. Okay, now. So resource, these are the daemons of yarn. Resource manager, this manages the entire cluster. This acts as the master process. Like name node in HDFS, here we have resource manager in yarn. So it is still made up of two processes, which is called a scheduler and application manager. But these two will not be exposed to us. But still, internally it is made up of two sub process, scheduler and application manager. Okay. And apart from this, we have one more called as node manager and application master. So even if we don't see the application master here, we don't see application master here, we will see only these. So what do we see, when we type sudo JPS or any UI error, we see only resource manager and node manager. Okay, when application master comes into picture, when scheduler comes into picture, application manager. So all these we are going to discuss here now. Okay, so simply remember that yarn is computing something, computing data. So where the data has to be, if you want to process the data, if Yarn has to process something, where the data has to be. So we have the data already in HDFS. That means all the worker nodes have the data. So we need to process the data by using Yarn. Yarn provides an environment. Okay, Yarn provides an environment where the data can be processed in a distributed mode. Okay, so what to do with one? What to do with Yarn actually? What we have to do with Yarn? So if you want to run any process in the sense, any data processing on multiple nodes and in a distributed fashion, this is called distributed computing. If you want to compute something in a distributed fashion, then go with Yarn. Yarn is one of the solutions. I don't say Yarn is only solution. Yarn is one of the solutions. Okay, and if we have the data, and I'm making a statement here, please make a note of this point. If we have the data in HDFS, if we have the data in HDFS, Yarn is the solution. Yarn is the only solution. Why? Because HDFS data can be processed only with Yarn. Okay, and if we have a data in other storage systems, right, there are other computing clusters are there. Not only just Yarn, there are other computing clusters like Mesos, standalone, and Kubernetes. So the different types of computing clusters are there. But if the data is in HDFS, Yarn is the perfect solution for it. Okay, and how do we work with Yarn? What to do? If you want to work with Yarn? What we have to do? Okay, what you do is submit an application to Yarn cluster. Okay, that Yarn will process that application, that is compute that application. So if you want to process any data, right, we need to submit that request in the form of an application. You getting my point? Okay, so the overall ultimate goal is we need to get some data processed. Okay, so how do we tell Yarn that? We need to tell Yarn that this is the application which processes this data. Okay, so everything has to be said in the form of an application and to be submitted to the Yarn cluster. Yarn will take care of that process. Got it? So how do we develop an application? What we have to do in order to develop an application? Okay, so the application has to internally it has to process the data. It should have the code. It should have the logic. Okay, so now in order to process any data, right, what is that? What is the needed, guys? In order to process the data, what is that needed? Any data. What is that needed actually? What is needed? Would anyone come with some question? What is needed?
The data structured.
No, don't worry about structure, semi-structure, and structure. Just what is that needed if you want to process some data? What do we need? So obviously we need data. So that is
Some
going to
query
be input.
language.
Right. So can't we process data with any programming language? Isn't it possible? We need some logic, right?
Yes,
we
sir,
need some logic.
Possible, sir.
Right. We need some logic. Sorry, it's going. We need some logic. That logic can be provided either by a programming language, isn't it? We read the language in a programming language. Whether use any language of our interest, we write some logic. Okay, we need data as input and some logic, and so data is there, logic is there, and what is the next thing that we need to run any job? I mean, to process any data. Guys, listen, we need some resources. What do you mean by resources? Suppose let's say that we have some correct. So CPU and memory, CPU and memory and disk also. Okay, these are the resources needed. These are the resources needed. Okay, see here, generally what by resource, which can be consumed to output something, to process something. Something has to be required. Something is needed to do something. Okay, So similarly in computer, if you want to play a video, if you want to edit something, if you want to do something, right, it requires some, some capability. So how that capability will be attained? That capability will be attained with the help of resources. Some number of CPUs, certain cores, certain amount of memory, certain amount of disk is required. Then only we can do some things. We can process some data, in any machine. This is what we need. So we need data, which is going to be the input, and we need some logic, and we need certain amount of resources, maybe 2 cores, 3 cores, it depends upon the amount of data that we process. Generally for playing certain video games, right, the memory or the CPU should be sufficient enough, should be sufficient, mainly with some mobile phones, right, some mobile phones which have some low memory, low configuration memory, let's say 1 GB or 2 GB, they don't support playing certain games. Why? Because the memory is not sufficient for, in order to play that game. Then it is lack of resources. You're getting my point? Okay, so data, logic, and resources. Got it? So in out of these three, among these three, we have the data already in, where do you have, where do we have the data already? In HDFS, right?
HDFS.
In HDFS, the data is already there in disk, that is in HDFS. And what about the logic? How do we write the logic? How do we write the logic? We need a programming language. Okay, so let's take a language called Java, or let's take Scala or Python, or any other language that have our interest, C++, AV language. Do you think just the language is enough? I mean, just the program language, or just the simple logic? Do you think, suppose I want to find all the cities with male population and female population of India. Okay, so can I write a program for it if it is a CSV file? Can I write a program in Java language or not? If there is a file, we want to process we need to get some insights from the data. Can it be possible to implement that logic in any language or not?
Yes, sir.
Yes, sir, it is possible.
Yes, it's possible, right? But remember, do you think the programming is going to be same? Listen to my question carefully, guys. Please pay some attention. So do you think the program is going to be same for the data on a single machine and for the data on a multiple machines? Why? Because HDFS has the data in the form of blocks, and these blocks are distributed across multiple machines. So do you think there is a difference between local file system and HDFS? So that means the file system in our laptop and the file system of HDFS, is the difference? Is there any difference? There's a lot of difference. There's a lot of difference. Okay. So whatever the program that we write in our computers, generally in our labs, right? Generally, in our labs, we write some program in some laptop or some desktop. But that program should work for the data that is in HDFS, not in local machine. Why? Because in HDFS, the storage style is different. The amount of data stored in chunks is different. So totally, the data storage style is entirely different. So we need to write a program such that it has to process the data that is present in HDFS. Why? Because HDFS has its own style of storing the data. Okay. So how do we know the style? How do we understand? Do we have any pattern for it? Okay, that is in HDFS. I want to code, but is there any pattern defined how to process the data that is in HDFS? Yes, the pattern, the programming paradigm for processing the data that is present in HDFS, right? That we have that program. One of the program paradigm is MapReduce. MapReduce program. Have you heard about this term? MapReduce program. Okay, so MapReduce program, it is a Java program. It can be written in Scala language. It can be written in Python language, but it can also be written in C+ language. But its the style is different. What do you mean by the style? Or its paradigm is different. Its pattern is different. What is that pattern? It is in such a pattern that it should understand the storage, the storage format of HDFS and it should read the data from HDFS and process it. Okay, so what do you mean by reading the data from HDFS? What do you mean by reading the data from HDFS? Reading the data from HDFS is nothing but it has to read the data from multiple machines in the form of what? In the form of what, guys? How the data is stored in HDFS? In the form of, you know, that is blocks, right? In the form of blocks. Okay, so when we say read from HDFS is nothing but it's not reading from D drive or C drive. It is reading from HDFS is nothing but reading from multiple machines in the form of blocks. And you remember the blocks are already replicated, but we should not read all the copies. We should read only one copy. You're getting this? So we have these many complications in reading the data from HDFS. We have these many complications. What are the complications? The data is divided into blocks. We should read only the blocks, and we should read only one copy of the block, not all the copies. So whatever the programming style or programming pattern, right? We have to program in such a way that it should read the data perfectly from HDFS. Such pattern is defined by MapReduce programming paradigm. Paradigm, PARADIGM. Don't get confused. It is a style or it is a pattern of doing something. Okay, MapReduce is one of the programming paradigms. Spark is one of the programming paradigms. Similarly, Tez is not a programming paradigm, but is an execution engine actually. But MapReduce and Spark, these are the programming paradigms. Okay, so suppose if someone asks you that I want to process the data present in HDFS. Okay, so what would be your approach? If there is some data in HDFS, we want to process the data in of that HDFS, some file, some data. So what would be your approach? Can someone come up, please?
So we write the MapReduce program and we send our programs to the locations where data is stored.
Okay, so we either need to write a MapReduce program or Spark program. Okay, that program, the Spark or MapReduce program, they have their own paradigm, programming paradigm. They can take care of how to read the data from HDFS, how to write the data from it. They will take care of. But I will show you a simple program that, okay, don't worry about that. But they're already designed. MapReduce or Spark are defined to read the data from HDFS. So we need not to worry about internals. How to what do you call as know which nodes have the data exactly and how to read only one copy of this blocks. So we need not to worry about all this. Those MapReduce or Spark paradigms will take care of that. That is the purpose of this MapReduce or Spark or this. They can understand that. That is how they have developed. They are developed. You getting my point? So which programming language we have to use for MapReduce programming or Spark programming? So we have different languages. I think I mentioned somewhere, but I will show you later. So typically these would be the languages for programming in MapReduce or for programming in Spark. Okay, so we have the data and we have the logic, and what else we need? We need resources. Okay, let's say I have 20 GB of data with me. I want, we have 20 GB of data in HDFS, and we would like to process this 20 GB of data. How many CPUs are required? How much memory is required? Can we make a guess? We can't really make a guess because there is no directly any mathematical formula to derive that these are the number of cores required and this is the amount of memory required for processing 20 GB. No, we can't just say that. It is not just only about 20 GB of size of the data. It is about the computing also. It's about the computing. Okay, it's about the computing also. That means how much how much complex the processing is. Depending upon that, we need to make a decision on the number of cores and memory. Okay, so overall, what I'm trying to tell here is we have the data in HDFS, and to process the data, we need some programming language. Just the programming language is not enough. We need to use either MapReduce paradigm or Spark paradigm to process this data with some programming language. And we need to specify what should be the amount of resources needed for processing the data. And once the processing is done, once the data processing is done, Where shall we store the data back again? The input is HDFS, we're processing it, and where do we have to store the data back?
Back into HDFS.
Right. So store the result back to HDFS. Okay. Now, reading from HDFS and writing to HDFS. Okay. MapReduce can only read and write it to HDFS. Limitation. One of the limitations of map, just make a note of all these points, guys. I may not write all these here. I may not put all these here, but just make it. So MapReduce is confined to reading and writing the data from HDFS. You getting my point? But Spark is not confined or restricted to read or write only from HDFS. It is almost very flexible in reading the data from multiple data sources. I can show you that all. I can show you that all maybe after a few minutes. But remember that MapReduce limitation is it can read and write only data from HDFS. Got it? So all these will make, so all this we need to wrap up as an application. Okay, so we need to tell all these in an application. That application we need to submit to Yarn cluster. Then Yarn will run that application. It's clear, guys? Okay, so all these we need to mention, all these we need to mention in an application. Okay, that application we need to submit to the cluster, and that Yarn will run that application. This is what we need to do typically. Got it, guys? Any questions? Before I proceed further, do you have any questions?
Sir, I have a question.
Yeah, please go ahead.
Does Yarn have its own compiler for these applications?
Your voice is very low, friend. Could you just increase your volume?
Okay, is it clear now?
Yeah, it is better.
My question is, Yarn has its own compiler or interpreter for compiling these programs, applications?
Yes. When we submit the application, right, it can, generally for working with MapReduce applications, we need to create a jar file. It doesn't do compilation automatically. We need to create a jar file, and that jar file has to be submitted to this Yarn cluster. But when we use Python programming, yeah, please go ahead. Please go ahead.
Yeah, that was my question also.
Yeah,
If it
yes.
is in Python.
If it is in Python, we don't need that. We need either a zip file .zip or directly .py file. That's it. .egg is not required. It is deprecated. So we can use either directly .py file. We need not to generate any jar file or anything. Nothing. Python is very simple. Just write Python program and submit it. That's it.
Thank you, sir.
So no need of creation of any jar, anything. That I will show you in a couple of minutes. I will try to show you all this stuff. Okay. It is clear. You need to understand this first, guys. Please. Yeah,
Sir, I
please
have
go
a
ahead.
doubt, sir.
Please go on.
Sir, what is actually the Yarn child, sir? Yarn child.
Yarn child.
Yeah.
There's nothing called Yarn child. The child processes will be there.
Yeah,
But Yarn
child process. Yeah, I read it from Tom White textbook, sir.
Yeah. We will discuss that. We didn't enter into the details of Yarn. Just I'm telling you what an application is.
Okay.
Yeah, we'll discuss that.
Okay.
So what I'm trying to say, so everyone should be able to understand what an application is. So if someone asks you what is an application, how do you develop an application? Then you say that an application these actually it should tell where the data has to be read from. It should tell where the data has to write back to. Return result has to return back to. It should tell what should be the amount of resources required for running that application for processing this data, and it should use any one of these languages to program. Okay, so it can be what should be the programming style. The programming style can be either MapReduce or Spark. So this will not come into picture here, either Spark, MapReduce or either Spark. Okay, so 1 second. Right. MapReduce application can be developed using program paradigm with Java, Scala, or Python. Similarly, Python. Sorry, Spark can be used developed by using Python and or language also. That's the reason data science people or machine learning people use this Spark a lot. MapReduce. So now MapReduce is deprecated almost. So no one is using MapReduce in industry now, guys. Please make a note of point this, guys. So MapReduce is almost, it's faded away. We have only Spark being used in industry now. So even if we forgot, even though we used a long back of MapReduce, we forgot how to use it now. We just remember the concepts only, but we still because we started using Spark more than 3 years ago, 3 to 4 years ago. That's the reason. So Spark has many flexibilities. We'll see how do we develop an application, how do we submit the application to a cluster. We are going to see in this session. Okay, is this clear? Still have any questions, guys? So that I can we can discuss. We can spend 1 more minute on this slide. Otherwise, we can just go with the next slide. Okay. With this. So now, what exactly a computing cluster has to do actually? So we have developed an application. Okay, we developed an application and we have submitted that application to cluster. What the cluster has to do? So what is that we are doing here in the application? We are saying that this is the amount of resources. This is the amount of memory we required. This is the number of CPUs required, and this amount of disk space required. So we don't tell actual disk space actually here, but we don't mention that. But still, it is being used. So we need to tell that application says that this is what CPU required. This is what memory required. This is where to read the data from HDFS, and this is a programming language. Mainly this is going to play a vital role. Okay, so now what the computing cluster that YAN has to do, what is that all to be taken care in order to run a process distributed environment or cluster, and what a cluster must be capable in order to run a process distributed environment, what the cluster has to do. Okay, so I'm we are having this multiple points here. Let's try to discuss one by one. First question, can we submit multiple applications to YAN cluster or not? Yes or no? Okay, so the answer for this question is yes. We can submit multiple applications to YAN cluster. Okay, YAN cluster. Someone is requesting access. Organizer, could you please take care of that? Okay, so can we run multiple applications on that cluster? Yes, we can. We can submit MapReduce application. We can run. We can submit Spark cluster. They can run parallelly and at a time. At a time, multiple applications can run on the cluster. This is true in case of YAN. Okay, next. Resource allocation, CPU, memory, and disk. Okay, so what are we saying in the application? The application is saying that this application requires this much amount of memory, CPU, and disk space. Okay, the requested amount of resources must be allocated by the cluster. That means whoever is maintaining the cluster, it has to allocate, it has to allot that sufficient amount of resources to the application. So yes, Spark YAN can do that, but who will do this? Okay, who will do this? We will discuss about that. Okay, and next, scheduled applications. What do you mean by scheduling the applications? So when we submit multiple applications, how the application should run? In data structures, right? When we in the very first year, of our BTech, and I came from engineering background, so I learned what we call as some data structures in my first year or second year. Stacks, queues.
Yes, sir. Yes, sir. It should be in queue, sir.
Correct, right? So scheduled applications. So the concept of a queue is what? First in, first out. So at a time, only application, the application that enters first the cluster, it is the application that runs, that comes after, that comes out of the cluster first. So it's a simply FIFO, first in, first out. So there are certain scheduling algorithms are there. Either whether it has to be first in, first out, or whether it has to be fair, or whether it has to be capacity. FIFO is first in, first out. Fair is nothing but equally distributing, equally allocating the available resources to multiple applications. Okay, that's one. First in, first out, running the application sequentially. And the capacity is nothing but we do specify the capacity. So let's say we have multiple applications A1, A2, A3, A4. We do allot some capacity to each application. Based on the capacity, the application will be scheduled in the cluster. Okay, so it is simply how to schedule one by one or at a time or based on the capacity. The capacity is something like when we visit certain temples, right, we'll have VIP tickets and normal darshan and VIP darshan, right? So capacity, who can pay more, they will be given the access to the visit first. Likewise, it's something like capacity priority. Based on the capacity, they will be given chance first. So fair is nothing but everyone is same, equally distributing the resources available to each and every application. FIFA is nothing but who enters first. I mean, sequence. It is in a sequence, one by one, one by one. So there is no capacity or fair. One by one, at a time, only one person. At a time, only one application. So based on our requirement, based on the cluster capacity, cluster resources, we can decide which type of scheduler we will use for our applications. That's up to us. But we have these two all. Next. I will come to this after some time, after discussing this too. Now, what if an application fails? What if an application fails? In case of HDFS, right, when we try to write the data in HDFS, if that write attempt fails, what is how to handle that? How that has to be handled? Retries. We need to make retries. Maximum of 4 retries. If that fail, then just again make a request to name node, get that data nodes or what do you call it, worker nodes list, and again start writing the process. Similarly, in case of yarn also, if the running application is failed because of some reason, it should retry. There should be a retry mechanism. So yarn has that. Yarn has this retry mechanism. So I'm telling you whether it can be, whether it has a capable to retry or not. Yes, it has that. Right. So here, this is very important. Create a separate daemon for each application or single daemon to monitor all application. Just read twice or thrice this statement, guys. Just spare some seconds. Create a separate daemon for each application or single daemon to monitor all applications. Just read, and can anyone tell me what did you understand by this statement? This one, the last statement.
We are talking about the instance created for each application.
So resource manager is one daemon. Okay, resource manager, there is a master process actually in yarn. Okay, so do you think the resource manager has to take care of all the applications, and or do you think it has to create another child process in order to monitor each application? Which one do you think it is better as preferred, recommended?
It has to create child process.
Correct. So at very high level, resource manager is the boss. It's simply a boss or master. Okay, but for every application, it creates a child process called as application master. That means one application master will be created for one application. It will monitor that application. If you submit one more application master will be created, and that will be assigned to that application. You getting my point, right? Okay. So resource manager creates child processes whenever a child process called as application master when we submit an application to the yarn cluster. You getting my point? So someone answered what is the child process, yarn child process,
Yeah.
something, right? So this is
Yes,
what.
sir.
Okay, resource
Yes.
manager creates application masters. So still there are many other child process going to be created as part of this, but this is where now create a logical space. This point, guys. Create a logical space where data has to be processed. Have you heard about a term called a Docker? Docker, DOCKER, Docker.
Yes, sir.
Containers.
Yes, sir. It
Containers.
has some containers.
nodes.
Containers.
Correct.
Containers.
Containers.
Yes, sir.
Correct. Containers.
So I think this
So
logical space corresponds to the Docker, sir.
No.
Container.
No,
Container.
no container. Docker doesn't come here actually, but we have the concept of container there, right? We have the concept
Yes,
of
sir. Yes,
container.
sir.
Similarly, containers will be created in Yarn also to process the data actually. Okay, so with the required resources, what are the resources we have allocated? With the required resources, logical space in the sense, the required amount of resources. With the available resources, a container will be created, okay, to process the data. But this is not Docker container. This is a container of Yarn. Okay, that's what I'm trying to tell you. Is it clear? Okay.
Yes.
So do you have
Container
any?
means you will have only CPU, all disk spaces available inside that, sir.
Yes. You know,
Is it the
yes,
working
yes.
environment or the execution environment?
I will tell you a simple
Right.
example. I will tell you a simple example. Just say I gave some work to you. I gave some work to you. Okay. Otherwise, we gave some work to our kids. Okay. Maybe some mathematical, some problem to our kids. So we ask them to solve it. So what they have to invest? What they do generally? So whatever the knowledge they have, what is the knowledge they have to bring all those, they have to bring together the knowledge whatever they have, and they have to solve the problem. It is something like utilization of bringing all the resources whatever they have, whatever the knowledge they have, that means bringing the resources they have, and with the help of that knowledge they can solve the problem. Suppose let's say that we have given a problem of addition, let's say. So they should have already the knowledge of how to do some addition, basic addition, then they can work on it. That means something like some knowledge. So similar to process the data, we need some logical stuff in the sense CPU and memory, mainly CPU and memory. Disk will be there, but that doesn't matter a lot here. But disk, RAM and memory, cores and memory, these two form a logical space in which the data can be processed. It is something like a space. It is something like a globe. You can just imagine as a globe or a box in which we have these resources, and the data can be processed in that container. Container, something like closed container. We have some data in it. We have the resources that can be processed in that container. You got this right? This is our. So before we proceed further, do you have any questions, guys? Here, is this fine? Okay, let's go to the next one here. Yeah, I think the questions here answer the questions here. Yes, let's go next slide here. This is important. This is very important actually. This is how the typical architecture of Yarn looks like. See the first point here. The resource manager is the ultimate authority that that arbitrates resources among all applications in the system. That means for every application we need certain amount of resources. So all those resources, who is the ultimate boss? That is resource manager. Okay, but you see there a statement to the right, totally right. The per application master is in effect a framework specific library, negotiated resource manager and working with the node man to execute and monitor the tasks. Okay, so remember that, just don't worry about this node manager and all this stuff for now. Just focus on only application master. Application master is a library, or it is simply a process which can be created for per application, one per application. Okay, next one. So see this here, see this, just focus on this diagram for a while. Okay, here we have some clients. So like we have clients in HDFS, here also same clients. They do submit the application to whom the application must be submitted. So in case of Yarn, in case of HDFS, to whom a request will be made to read or write the data. In case of HDFS. In case of HDFS, to whom the request has to be made?
Node masters.
Node manager. Name node.
Node manager.
It is a name node, right? Master process.
Yes.
Okay.
Yes.
Similarly, in Yarn, the master process is resource manager. Similarly, the master process in Yarn is resource manager. So the client should make a request. So what does the client say that take this application and run, and they will submit that application to resource manager. So when this application is submitted, what does the resource manager do? Just make a note of these points, guys, please. The first point, client submit application to resource manager. Okay. Secondly, what does the resource manager do? The resource manager creates what? You have to tell me. Creates what? Application master. The resource manager creates application master for that application. Okay. What does the application master do now? The application master has to create the required number of what? Here we do have in the last box we have something in the bottom. What are they? Containers. Just now we have discussed containers. To process the data we need containers, right? So resource manager directly doesn't create containers. Resource manager creates application master. The application master creates containers. The application must create containers for processing the data. Okay. How does the application master can create the containers? With the help of node manager. Just don't get confused about all these. Just make a note of points. If you're noting down, I'm repeating the statements again. Clients make a request to resource manager, okay, to process one application. That is, clients submit one application to resource manager. Okay. Next, resource manager creates one application master for each application. Okay. Next, third point, each application master creates containers for the application with the help of node manager. You're getting my point? With the help of node manager. That's it. Once the application processing is done, containers will be destroyed and application master also will be destroyed. Once the application is completed, application master and containers are going to be destroyed. You got this point, guys? Okay, this is a typical life cycle of any application. Application submitted, application master will be created by resource manager, and application master creates containers with the help of node manager, and once the application processing is done, application master and as well as the containers created are going to be destroyed. This is the typical flow. That is what we see here in the right side, right? This application master is going to create containers with the help of the node managers. You see this, and working with the node managers to execute and monitor task. So everyone in this session, guys, you should understand the right, the statement that we have here in the the right side about this application master. This statement everyone should understand. Please let me know if you have any questions, but you should understand. If you don't understand, this session is of no use. You have to understand. Please let me know. I will wait for some time, for a few minutes. Please go through this and try to understand about this diagram and everything. If you have any question, a simple question or anything, please let me know. I will try to explain one again and again. But you have to understand. Please ask me questions if you have any. I will clarify them. Okay. So if you have no questions, I will ask the questions. So you should answer that questions. Okay. So I'm going to answer these questions. Just tell me what are the answers. What are the yarn master and slave daemons? What are the names? Tell me. Resource manager.
Application master.
Application master.
Master.
So application master will be created only when application is submitted. Okay, remember, application master will be a child process will be created only when application is submitted. Okay, still not a problem. We can do that. And
node manager.
Node manager. Got it? So you understand my overall intention. You should understand everything, whatever we're discussing here. That's my point here. So containers, application master, all these come into picture only when we submit an application. Otherwise, when the always we'll have only resource manager and node manager. That's it. Okay. You can use containers also here, but this is not a process actually. Next, what type of application does Yarn support? What type of applications? MapReduce. We can submit MapReduce application as well as Spark applications. This also, but it's not an even you can call it as application, but it's not a program paradigm. Now, what is a container? What it does? What is a container?
Collects all resources required for the application.
Correct. It encapsulates all the resources required for processing the data. Okay, so processing of just logical space for processing whatever I think already we have mentioned the last page processing data chunk for processing now, and container processing chunk is called a task. So don't get concerned about task. What is the task? In operating systems, in our I learned all this during my academics. Process in operating system, the very first unit or second unit, I don't remember exactly. The concept of process and process thread task there. A task is a unit of process. It is it is a simple process, something like that. Okay, so a container processing a chunk of data, that is called as a task. Task is nothing but doing something, right? That processing, when container is processing some chunk of data, that is called as a simply task. That's nothing else. Okay, that question I have here already. What is a task? So a container processing chunk of data, that can be called as a task. Okay. Next, how does Yarn effectively ensures effective utilization of resources? So we have resources across multiple machines, right? RAM and CPU cores. How does Yarn ensures effective utilization of resources? That means Yarn should understand always should ensure that I'm utilizing the resources effectively. I'm not wasting any of my resources. How does it ensure?
Through the resource manager.
Yeah, that is fine. The resource manager is going to take care of overall. Ultimate boss is resource manager, but how does it ensure something? How does it ensure? Well, let me put the question in some way like something like this. So we have a cluster, Yarn cluster, and today we have submitted 10 applications. Okay, and tomorrow we have only 3 applications running on the cluster. Okay, only 3 applications running, and maybe the next day we don't have any applications running on the cluster. So what should happen to the resources? So the resources should be always be consumed, irrespective of the application's deployment, or the resources must be consumed only when the applications are deployed.
So through scheduling, sir.
Scheduler, sir.
Yeah. Correct. So the thing is, there is some concept called as dynamic allocation of resources. Dynamic in the sense, what I should say. So whenever a process is in action, whenever application is under process, right? In what way the resources have to be allocated for that application? There are 2 ways of allocating resources. One is dynamic, another one is static allocation. I think you must know about the difference between static and dynamic. So dynamic is nothing but whenever there is a need for the resources, it will be used, and whenever there is no need for the resources, they will not be used. Are you clear? Are you confused about the statements? So you may ask a question here. I have a question. If you don't have any question, I have a question. The question is, when we submit an application, obviously the resources must be consumed, right? then why we are talking about the dynamic and static? What is the meaning of allocating static and dynamic? So guys, remember for certain applications require only the memory a lot. Certain data processing require memory a lot. Certain data processing require CPU a lot. CPU intensive operations will be there and memory intensive operations will be there. Just please make a note of point on this. CPU intensive operations and memory intensive operations. So when we are processing the data which require high memory, CPUs may not be required. CPUs may be required, but not to that extent. In that case, we should limit the usage of CPUs. It seems a bit confusing, but when you go this, I can explain you with this AWS VM types of pricing. Yeah, let me show you this. So there are machines. I think on demand I can show you here. Okay, so these are all the machine types here. General purpose machines. These are different types of machines that we have. 8 GB, core, the number of cores and the number of amount of memory for each. And if you scroll down, you should see something called as, do you see something here? What is this? Compute optimized. And this is compute optimized. And scroll down a bit again. GPU instances and memory optimized. We have two, compute optimized and memory optimized. What do you think the difference between these two? So if you observe memory optimized, memory would be very, very higher here. Do you see the memory here? What is the amount of memory here? 976 GB, 1952 GB. 3904 here, the amount of memory is 394 GB. So we have in real time, right? We have certain applications, some data where it requires high memory, very, very high memory. And there would be some data sets or some operations which would require high number of CPUs. So wherever high memory is required, we have to go with memory optimization machines. And wherever CPU is highly needed, we have to go with CPU optimized machines. Okay, so wherever Yarn encounters compute optimization machines, compute optimized operations, it will automatically consume only the CPUs. It will leave the memory behind. Similarly, when it encounters memory intensive operations, it will leave CPUs behind and it will utilize the memory to the required extent. This is called as dynamic allocation of resources. It is something like whenever something is required more, acquire it. Whenever something is not required, leave it. You're getting my point, right? It's very dynamic. It's something like adaptability, adaptability to the situation. So whenever something is required more, acquire it. Whenever something is not required, just leave it. You're getting my point, right? So I can explain you a bit in a simple words. Let's say 4 cores and 8 GB. So we have, let's say for some application, for some data processing, we have allotted 4 cores and 8 GB. Okay, but for that application, we don't need 4 cores. Only 2 cores are enough and only 5 GB is enough. Then what will happen to the remaining 2 cores and 3 GB of memory? What should happen to that? What should happen? So in case of static memory allocation, whether we use 4 cores or not, entire 4 cores will be utilized and 8 GB will be utilized. In case of dynamic allocation, it will use only 2 cores and 5 GB of memory. You're getting this? Just listen to carefully. We actually have these resources, 4 GB, 8 core, so 4 core, 8 GB memory resources are there with us. But application, whatever application we are running, that requires only this. But what we said in the application, right? But what we have instructed in the application, use 4 cores and 8 GB. But when we say static memory, it will use 4 cores and 8 GB whether it needs or not. But when we come to dynamic, it uses only the required amount of resources, leaving behind the unwanted resources. This is called a dynamic. That means acquiring the resources whenever required or leaving the resources when not required. This is what the dynamic allocation of resources is. So Yarn has that capability to identify whether the resources are being used or not. If the resources are not being used, it will leave the resources. If the resources are required, it will acquire the resources. So that is the concept of the dynamic allocation of resources. So there will be a question, in interviews generally we ask the questions people that how do you optimize the applications on a Yarn cluster or any cluster? So one of the answers must be we always go with dynamic allocation of resources, not static. Okay, it is something like some people eat food whether they are hungry or not, they eat food, that's it. But some people, right, if they feel hungry, then only they eat the food. There's something like, static is something like whether not required, consume everything. Dynamic is something like if you need, use it, otherwise just leave it. That is the meaning of this dynamic and static. So which one we would prefer always is dynamic allocation of resources, always. Is it clear, guys? Still have any questions? Could you let me know, please?
Clear, sir.
But this is actually large, it's a large concept and typical concept, complex, concept to understand. But we have time concept. I can't explain in detail everything. This is what I can just explain you for now. Right. Next question: can an application be killed? Suppose we have some issue with the application and it is not running at all. It got stuck. Can we kill it? Yes. Yarn has the capability. With Yarn, that we can just directly kill an application. If you do not want it to run no more, yes, we can do that. No, this is again going to be an important discussion here. How to deal with long running tasks? What do you mean by this? Suppose let's say you gave some work to some of your team member or your subordinate. Just do this work and give it to me. So ideally that work should take just say 1 day, but it's taking 3 days, 4 days, but still not able to complete it. What would you do? Generally, right? Generally, what we do. That means it is taking more than expected time to run. What we have to do in that case?
So it will given to number of people.
No. Ideally, it should be completed. If it is not able to be finished by one person, we can distribute across multiple machines. Distribute other people also. But that can be done easily. We know that it can be done with one person, but still is not able to do that because of some reason. It could be because of some reason. Maybe he's not interested, maybe or something, whatever it may be. So what we do in that case? Shall we fire him, or what we do? It is very simple, right? The question is very straightforward. Suppose if someone is not doing that work in the given given deadline, or he can do but is not doing, maybe because of some reason. It's maybe his fault or
So
something.
don't use appraisal. Don't recommend me for appraisal.
It's not appraisal, but let's say that he's not feeling well, or maybe he has some issue with some family problem, something like that, right? In that case, we can't go.
It will be
Change the employee. That means give the task to other employee.
Because
other people.
that's
Other
it, right?
person.
That is the only solution we have. We don't have anything else. So that is called as, even in sometimes, right, when we run some process or jobs, right, they take longer than the expected time. Actually they're taking long. In that case, it is not only just all the machines, but some machines, some nodes, they take longer than the expected time. In that case, how we have to deal with it? So there we have a concept called as speculative execution. Yarn has internal, we not do anything for this. Spark internally has a feature called a speculative execution. If one of the nodes is running slowly, is not able to complete the process quickly or in the expected time, Yarn will automatically spin up a feature called as speculative execution after a certain interval of time, and it will try to assign the task to another node. It will cancel the task running on that node and will assign the same task to another node. Do you think so? Here, guys, you should understand very clearly here, very clearly here. This is very important concept, this speculative execution. So if one node is not, just listen carefully, if one node is not able to process the data in the given time, in the expected time, Yarn will assign the task to another node. Okay, this is perfect, there's no questions in this. But what will happen to the data? Do we have the same data that was there in the previous node in another node? Let's say we have a node, let's say A, and in that we have some data called as D1. So this process, the node A is not able to process the data in the given time. So now Yarn has make a decision to process the data in B, in the node B. But what about data D1? Do we have data D1 in B? Where do we get the data from into B? This is where you need to think, guys. We have the answer already. We have one copy of data in A, and to which machine Yarn has to resubmit the job, to which machine? So is there any chance that we'll have another copy of D1 in any other node? Is there any chance? Guys, think. In the morning we have discussed SDFS replication, right? In the morning we had SDFS replication. What is that SDFS replication? We have the same copy of data, 3 copies, in multiple machines, right? So if A is one of the nodes which is having one copy, and B is another node which should have the same copy, this D1, then only this speculative execution is possible. That means speculative execution is possible only we have multiple copies of the data, not just only one copy. We should have multiple copies of the data. That is the speculative execution. Okay. Next, what are these HTTP ports of Yarn demands? Like we have HTTP ports for SDFS. Here we have HTTP ports for Yarn demands. I can show you that. So EMR, if you see a resource manager here, the UI. Sorry. 1 second. Okay. So this is the UI of Yarn. This is UI. So what is the port number here? 8088 is the HTTP port number of Yarn. Okay. Just I'm writing these values here. You can do it later. 8088 and 8042 is the port number of this what you call as manager. Okay, and RPC port numbers 8032 and 80. I don't remember exactly what is the number here. I don't remember exactly, guys. Just you can refer to some notes. Maybe I will give you later about this value. But this RPC port and RPC dead nodes will not have RPC. Sorry, only. Sorry. RPC port number will be available only for master process, not for slave process. So RPC port number of resource manager is 8032 and ST port is 8088. Okay, so is this theory part clear to you guys? I'm going to show you some practical stuff now. Is this theory part clear to you, or do you have any questions? Let me just prepare the slide, and I'm just walking through each slide. I'm navigating through each slide. Please just focus and let me know if you have any questions before we proceed to practicals. So obviously we need to spend some time, some hours in understanding a distributed computing. Distributed storage would be easy to understand, but computing would be a level of difficulty will be there in understanding computation. Okay. So are you okay with this now, guys? Any questions?
No, sir.
Right. Thank you. I'm going to launch a simple Spark application here. Let's see how that works and how it will be shown. Let me just show you. By Spark. So I'm launching a Spark application here, and we are submitting that application to Yarn. But you have to tell me, guys. You have to tell me if I'm missing anything here, or because whatever we have discussed in theory, that we have to see in practical. Am I missing anything here? So I said you right, when we submit any application, what is that I told you? When we submit an application, what is an application made up of? Some language and some amount of memory and CPU, and we should read the data and read and write the data from HDFS or some other location. Okay, did we miss anything here? So all this satisfied here? Just remember these all four and see whether all these are satisfied here. What is that we are doing, and what is that being satisfied, or is something missing here? Why are you not asking me here that where did you specify the number of CPUs? Where did you specify the number of amount of memory required for this application? Did you tell me that? Are you asking me that? Why are you not asking me that? Guys, you understood, right? Don't worry about this application here. Just I'm trying to Spark a Spark application to whom I'm submitting the application, to whom I'm submitting this, that we have to specify in the form of master Yarn. We are trying to submit to Yarn, and don't worry about this. This is again a long concept actually. How many cores you need to provide? How many cores you need? That we will specify. I'm telling 4 cores. And memory, how much memory you need for this application? I'm telling, let's say some 8 GB of memory is required. And total how many containers you need? I need some 4. Okay. And where do we specify input and output? That I'm going to show you now. What happened? Required executor memory overhead 1536 memory. So there is some memory issue here. Memory here. Okay. Resource memory MB. It can't be 8 GB, I guess, memory. Well, because we have less amount of memory here actually. There's the reason not showing that. But because we have only 3 workers, right? There's a limitation here. So what is this type of application, guys? It is a Spark application or MapReduce application? Would you tell me that? Right. Just go to the UI, Yarn UI, and just refresh this page. Do you see something here? By Spark shell, and what's the type of application? Spark application, and the status is running here. And how many containers are created? 3 containers, and allocated virtual cores 3 cores. So how much memory is allocated? This is a memory. So whatever the request we made, based on the request we made regarding the number of cores and amount of memory, and how many containers must be created. So based on this configuration, the application is going to be created here. Okay, so we need some we need some more time to understand all these, why containers are 3, why the codes are still showing 3, and what is this. We need some extra time to understand all this. But just for remember that when we deploy an application, that application will be directly shown in the UI, in this UI, and the application is showing that the application is here, it is running here. You're getting this? Okay. And similarly, if we submit any map, I don't have directly my Maps application with me right now. I don't have the jar file. That is why I'm not able to show that. But it will be same as this only. But we need to have the jar file. I did not create the jar file. That's why I'm not able to show that. But similar, it would be very similar to this. Okay. Any questions here, guys? Here or here? Please let me know. And we would like to read some data from HDFS. So where do we have the data in HDFS? In HDFS, go to the file system. I will just show you how do we read and write the data. That's it. Okay. User Hadoop. In user Hadoop, we have some file called as call data here. Call log data. In user Hadoop, there's some file called as call log data. Okay. We will try to read this file in Spark. Okay. Let's see how it works. Something like this. C.text file. So don't worry much about this. User Hadoop. What is the file name? Call log data. Okay. Let me just show you the sample data. Okay. So this statement, whatever I'm written, sc.text file and user Hadoop call log data, right? This is reading the data from HDFS in Spark. Okay, reading the data from HDFS in Spark, and out of it, I'm just printing the top 5 records. We are not doing any typical operation here. Maybe we can have one more session if required to discuss about how actually we do analyze the data. I think someone was asking in the morning that how do we analyze the data actually by using this framework, Spark or MapReduce. So I think it requires a complete day session actually, one complete day. I'm not sure we have that bandwidth or not. So because of time constraint, I'm not able to show all this. So this is how we read the data into Spark and doing some computation on this. Okay, I can show you. Okay, so this is some data we have. If you see, do you see this here? Each record, this is one record, and this is one more record in the file. What are the files that we are reading here? Okay, and this is one more record. Where is that completed? Here. This is one more record. Likewise, we have different records here. Total how many records? We can see the number of records of that particular file by using an operation called as count in Spark. So it will give the total number of records that we have in that file. How many records in that file? So total in that file we have 8,23,741 records are there. Okay, so do you want me to do quickly any operation on this data, any analysis on the data? Just to take a look at the data and tell me, or I will just try to open the data in my I have the data in my local machine. I will just open the data very quickly, and if you want me to, this is the data that we have actually. This is the data that the same data we have loaded into HDFS, we are reading from Spark. So if you want me to, just by looking at that, if you want me to do any analysis, I can show you that very quickly. How really we do some analysis.
Can we modify or something?
Yeah, that's what I'm telling. I'm giving option to you. Do you want what do you want me to do?
Or if you want to modify any of the, let's say you took 5 records, right? So from that, if we want to modify the first record and again print it, then is it possible?
modify first record.
Or is just the deletion or the retrieval is possible? I am not sure about this,
Okay.
so that's why I'm
Okay.
asking.
Okay. So here you have in every record we have a status. This is a call log data actually. So in every record we have a status here. You see in the very first record we have dropped here. The second record we have success. In the third record we have failed. So likewise each record has a status here. Okay. So shall we find out how many records or dropped records?
Yeah, sure. Yes.
Yeah. So how do we do that? It's very simple here. Instead of doing count, right, what we need to do is apply filter. This is the language of what you call as Spark actually. Don't get confused. If you want, we can have one more session. Just talk to it in organizers. We can have. So lambda x success in x. Sorry. So if someone is already familiar with Python language, they should understand this. So we are filtering on only the records where we have success in a record. Okay, so what would be the count of that? If we do this filtration, if it see so total we have 8,23,041 records, and out of them how many are success records? So we have around 6,43,621. Okay, so if I want to save only the success records into HDFS as some file, we can do that. So let's say this is the expected output that we are expecting, and I would like to save this data into HDFS itself. So into HDFS user Hadoop, I say success data. I simply call it success data. So now this particular statement is reading the data, and it is filtering, and it is retrieving only success records, and is writing the result to HDFS. HDFS, what is the path here? User Hadoop success data. Just go to HDFS and go to browse the file system, and let's navigate to user Hadoop, and here under Hadoop you should have the success data. Do you have this directory? Yeah, you have this directory here, success data. You have this part 000, part 0001. This is the outputs. So the output is always a directory, not a file. The output is always a directory, remember. So why this directory? Why do we have two files created here? So we have answers for each of these, but that would take a lot of time to understand, to discuss all this. But this is a typical scenario. Okay. Is it clear, guys? Any other questions we have? Yeah, please.
Can you show the notepad, sir? That notepad file.
Okay.
So in the command you gave X, right? So what it stands for?
Right. Let me just show you that. Filter lambda x. Do you know about lambda functions? I will explain that. Don't worry.
Yeah.
I will explain that. So let's say that if I write something like this. Equal to sum plus 1. If I write something like this, sum equal to 0. What is I here? For I in x, sum equal to sum plus 1, or sum plus I or sum plus 1, what it may be. Okay, so what is I here?
Variable then, like a Python. Yeah. Okay.
Correct.
Okay.
That's it. So instead of x, we can use your name, my name. Anyway, it's just an alias name. It is simply a temporary variable. That's it. Got it?
Yeah, got it. But sir, it's not that we need to read column by column. It's not like that. It's randomly reading, right?
No, it reads all the data sequentially, one by one, everything, all the records.
Okay, sir.
All the records, not randomly, all the records.
Thank you.
So it's up to us whether to read all the records. After reading all, whether we just confine to only take 5, nothing but accessing only the top 5 records. If we want to record all, that depends upon the business.
Sir, one question here.
Please.
In this file, we don't have labels on each column, no? I mean,
no, we don't have.
I don't see labels here.
No, we don't have it. I mean column names, right?
That's why I put it this question actually.
You're talking about column names?
Sir, I mean the headings are not there.
The header part, So we don't have header part here. But do you think is it a structured file?
No, it's not structured, sir.
It's not structured, right? So
Yeah,
shall we see a structured file, a CSV file, and try to read that file? Yeah, we'll try that.
I think we can migrate to CSV.
Yes, we can do that. So let's say have a simple file, a CSV file, and let's work on that. Let's say there's some ID, name, let's say some city. Let me take some 201 is 210 is some ID. Let me take name as some Siddharth. 310. Just I'm taking a simple data, not much. Nataraj. Let's say Pune. Okay, just I'm copying this. I'm saving this file. Desktop sample file. I'm calling it as sample file.csv. Okay. So now can we upload this file to some location? Is it possible? Yes, right. I will choose a file. Sample file. Where do you have the sample file? Yeah, sample file.csv. Open it and upload it. So we have that sample file .csv in HDFS. User Hadoop sample file.csv. Okay. Let me show you that. Spark dot read dot. So what is the file format? It is CSV, right? Format of CSV file, and option of so this is the typical syntax of Spark, guys. Don't get confused about this. User Hadoop and the sample file .cs. Sorry.
Can you break the statement, sir? Is it possible so that we can understand well?
This is a complete one statement. We can't just break it. This is complete one statement. Okay, yeah, otherwise I can show you that. So it is reading now. This is data from HDFS. df.show. We got it. ID, name, and city. You got it as a column. It is a table, right? ID, name, and city. This is very simple.
So you converted into data frame, right, sir?
Data frame, yes, data frame. The structured data can be directly created as a data frame. That's what I created data frame here. Similarly, for JSON file or XML file, anything, right? They can be easily converted into a data frame. This looks like a simple table. This is, see how easy in Spark. Create a table out of what you call as a file. That's it. So it can be whether it is millions of records or it is simple 2 records or anything. Just this is the only statement. Irrespective of the size of the data, this is the only statement to create a data frame or table. It is something like a table in any RDBMS. It's very simple. So if you want to do the same thing in MapReduce, it is very difficult actually. Not difficult actually. Lengthy code and lengthy programming. So there's the reason we have everyone started using Spark. That too, Spark is very powerful in performance or processing or whatnot, everything compared to MapReduce. Okay, clear, guys?
Sir, you are this statement that you wrote. This is Spark language only, because you said in Spark we can work in Python, R, and different languages. So right now you are using Spark environment language only.
Correct, Python API, but Spark has its own set of functions. Okay. In pure Python, we don't have anything like read dot format of CS, something like that. But the syntax is same as that of Python.
Right.
Got it? That's what I'm telling you. Python API. That's what I'm telling you. Python API.
Okay.
Python API. Scala API. That is what I'm telling you. Got it?
Okay, sir.
Right. So I'm just closing this application, guys. Just I can say sc.stop. The application is going to be terminated. Now, I will show you. Actually, I will be discussed tomorrow in your in the tomorrow's session. Just I'm trying to show you how do we launch a Hive, and how that will be shown on Yarn actually. So when you start Hive here, just go to the UI, Yarn UI, and you will see something different here. This is the Hive application. This is the name of the application. And what is the type of application here? Do you see here? This is a TEZ application, TEZ. So Hive can use either TEZ. Just please make a note of points, guys. Hive can use either TEZ, either Spark, or either MapReduce as its backend engine. I'm repeating the statement. Hive can use either MapReduce, either Spark, or either TEZ as its execution engine. Okay, in MapReduce, sorry, in EMR, in AWS EMR, you know what, the backend engine is TEZ by default. Why? Because TEZ is faster than MapReduce. I think maybe in tomorrow's session, the speaker may go with Hive with MapReduce or Hive with Spark as backend execution engine. That's what I'm telling you. It either TEZ or either MapReduce or either Spark. Any one of these can be the execution engine of Spark. That's what I wanted to show. There's a reason I have launched this Spark, this application here. Sorry, not this, sorry, Hive application, Hive prompt here. Okay, so if we don't have any questions, we can, so now we shall allot some minutes for questioning answers. If we don't have any questions, we shall wind up the session. And if we have still anything to discuss more about Spark or Hive or anything related to this, we can do it maybe on. We have one more session on Friday, I guess. We can discuss on that day. Over to you, madam. If we are, I don't know, organizers, I'm not sure. Is that? Hello?
Participants, do you have any queries?
No, ma'am. Thank you.
Okay, ma'am. Sir, thank you very much, sir.
Thanks, madam. Thank you.
Thank you, sir.
It was huge knowledgeable.
Thank you, sir, for this
Yeah, sir.
practical
It's very good
explanation.
session,
It
sir.
was very good.
Yes, sir.
Sir,
Thank
that
you, sir.
presentation, sir, that presentation, if you can share with us, that will be
Yes.
little help.
Yeah, that I will
Sir.
share with the organizers team. They can share
Sir,
with you. They will share with you for sure.
All the presentations, all the links will be shared, but give us some time.
Yes.
Don't worry about the material at all. We will be sharing with you.
Okay.
Thank you, sir, and thank you, participants. Tomorrow session will be at 10 o'clock.
Thank you, sir.
Thank you.
Thanks everyone. Thank you.
Thank you, ma'am. Thank you very well.
Thank you, sir. Thank you, ma'am.
Thank you.
Thank you, sir.